one more example of being able to use the law of cosines to be able to solve triangles. So we have a diagram in which we have this triangle, but we don't necessarily have any of the interior angles, nor do we have all three sides, right? So we're just going to have to use a little bit more information. So one thing that we know is that this line is a straight angle. Okay, so the big solid dark line there. And so we know that straight angles have a 180-degree measure, right? So we know that the total has to be 180. Okay, and so all we have to do to find this interior angle C is take 180, subtract 16 degrees, and also subtract 36 degrees, which is going to be 128. So this interior angle should be 128 degrees. Okay. Now that we know that, we can go ahead and use the law of cosines, because we recall that one of the rules says that the cosine of C is a squared plus b squared minus c squared divided by 2ab. And we know all the components except for c squared. And once we solve this, we could be able to find c squared rather easily. So cosine of 128 degrees is going to be equal to a squared, and we know a is 14, plus b squared, 8 squared, minus c squared, which is the unknown, divided by 2 times 14 times 8. Now, 2 times 14 times 8, I can shove into my calculator, and that's going to wind up to be, I believe, 224, which it is. Okay, and so since this is 224 in the denominator, what I can do is I can multiply both sides by 224. Okay, that would cancel out the denominator. And then also I can subtract 14 square and 8 square. So my expression now becomes 224 cos of 128 degrees minus 14 squared minus 8 squared equals negative c squared. Now let's compute this expression, okay? And we're just going to go into our calculator, and we're going to say 224 cosine of 128 minus 14 squared minus 8 squared. All right, and we get negative 137.91, or negative 397.91 is equal to negative c squared. We can divide both sides by negative 1, and now we can take the square root of both sides to get what c is, okay? It's looking like, since this is almost the square root of 400, we should have like 13.9 or something like that, just as a guess, but let's just go ahead and figure it out. So we're going to have the square root of 397.91, or 397.91. And that's going to be 19.94. Okay, so we'll just say 19.9. All right, so that's the measure of side C. All right, now we know both an angle and we know one of the side measures. So now what we can do is we can go ahead and use the law of sines. Recall, sine of A divided by A is equal to the sine of C divided by C. And we don't know what the angle A is, but we certainly know that side A is 14. Okay, so we just go back up here. That's going to be equal to sine of the angle that we got, 128, and we're going to divide that by 19.9. Now we're going to multiply both sides by 14, and then we can take the inverse sine to be able to solve for A. So A is going to be arc sine, or sine minus 1, of 14 sines of 128 divided by 19.9, right? And we could just throw that into our calculator, figure out what A is approximately to 1 decimal place. And so we're going to take the arc sine of 14 sine 128, divide 19.9. Oh, I'd rather divide symbol in there. That would probably be helpful. All right, and put that in the denominator. right, and we get 33.7. Okay, so that's going to be 33.7 degrees. And now mercifully, we can finish this off because we know angle C, we know angle A, we know that interior sum is 180. So for angle B, it's 180 minus 128 minus 33.7 degrees. Okay, and if we subtract those out, we're going to get 180 said minus 128 minus 33.7, we get 18.3 degrees. All right, so now what we can do is we can say, okay, we can find this the measures of our triangles by using a combination of laws and sines and cosines. One of the next things we're going to take a look at is the area of triangles. And one of the sort of offsets of this is being able to find the area given two sides and an angle. All right, so if we know two sides and an angle, then one of three formulas can be applied depending upon which sides we have. All right, so we could take 1/2 of BC sine A, or 1/2 of AC sine B, or 1/2 of AB sine C. Okay, we just substitute them directly into the formula. So this is actually really easy for us to compute. So let's say for some reason we had a side A of 50, a side B of 70, and then an angle between those two sides of 60. Well, I can just go ahead and use this formula right here. And so our area is going to be 1/2 of 50 times 70 times the sine of 60 degrees. If we multiply a half times 50, that's 25, 25 times 70. That's going to be like 1750 or something like that. So let's just figure it out. So we have a half times 50. Nope. Try that again. 1/2 times 50 times 70. Oh boy. All right, so that's 1750. We know that the sine of 60 is √3/2. So an exact value, if we wanted to, we could get 1750 times √3/2. The exact value of this, we could just divide 1750 by 2. Okay, so 1750 divided by 2 is going to be 875, or if you don't believe me, so it's going to be 875 square root of 3, okay? Or if we just wanted an approximation, and this would be in centimeters squared, so this would be the precise value. If we wanted an approximation, we could just go into our calculators and take 875 times the square root of 3, and that would be 1515.5. So 1515.5, again, centimeters squared. Finally, if I had this sort of angle where I had B and C are 16.3, I'm sorry, B and C are given, and unfortunately, we don't have angle A. But what we could do is we could find angle A pretty easily, all right? Notice that we could start by using the law of sines to find angle C for this, okay? So that's what I'm going to do is let's find sine of C divided by 0.387. Okay, so remember sine C over C equals sine of B, which in this case is 16.3, divided by 0.923. All right, we can multiply both sides by 0.387, find the arc sine. So we could say arc sine of 0.387 sine of 16.3 degrees divided by 0.923. And if I just punch that in my calculator, all right, we have the arc sine of 0.327 sine of, or it's 387, excuse me. So 387 sine of 16.3. And we're going to divide that by 0.923. And that's going to give me 6.76. So we could just say 6.8 degrees. All right, so pretty small angle there. Okay, so 6.8 degrees. Okay, and that's going to be angle C, right, which makes sense because if this one's only 16.3, and this is a pretty relatively bigger angle than this one, then that makes sense. And then to find side angle A, all right, because remember, when we do this, we have to look at our formulas, and our formulas, we need the angle A if we have sides B and C, but we can figure out angle A easily. Okay, so A is going to be 180 degrees minus 16.3 degrees minus 6.8 degrees. Okay, so it's going to be a pretty big angle, right? It should be like 100 and probably 67.1 or something, or 0.9, but that's fine. So we'll just go ahead 180 minus 16.3 minus 6.8 degrees. All right, so 156.9. Just making sure. Yep. So it's going to be 156.9. Now, finally, we can go ahead and we can say that the area is going to be 1/2 times B, which we know to be 0.923, times C, which is 0.387, times the sine of A, which is 156.9 degrees. All right. Now let's just go ahead and shove that all in our calculator. All right. So we're going to have 1/2 times, we said 0.387 times 0.923 times the sine of our 156.9, and the areas would be 0.070. Okay, so we'll just say 0.07 meters squared. All right, so that's how we can go ahead and try to use these formulas to find our areas. Okay, now we have one more type of problem with area, and we'll do that in the last video, and that's where we have we're going to have 3 sides as opposed to 2 sides at an angle. All right, so and we're going to use something called Heron's formula to be able to do that.